So here's the worksheet that I have for you on Schoology, and you see that there's some of the units up there at the top for you. I'm a nice guy and I gave those to you, but again, we're going to want to memorize those. And to give an example problem here, the first question says, the air pressure for a certain tire is 109 kilopascals, kPa. What's this pressure in atmospheres and what's this pressure in millimeters of mercury? So I'll start with what's given to me, 109 kPa. I'll put kPa at the bottom, 101.3 kPa. And what am I converting that to? I'm converting that to ATM, so I'll put 1 on top. So 109 divided by 101.3 is equal to 1.08 ATM. Okay, so that gives me my value in atmospheres. I'll do the same thing for millimeters of mercury. I'm kind of tight for space here a little bit. So I'll do it up here. So I'll start with what's given to me, 109 kPa. My conversion is 101.3 kPa on the bottom, 760 millimeters of mercury on top. What do we get when we do that? We get 109 times 760 divided by 101.3. And that unit of pressure, that value is 115 millimeters of mercury. There's my answer there. This was my other answer down here. Those are equivalent to one another. They're just expressed with different units. So it's like the same stuff that we were doing with the moles. We're just using different units to express that value. And those different units depend on, we're going to see that the units that for pressure they can vary, but the units that we're using are particular to some of the formulas, so we need to be familiar with converting between them. So at the bottom of the worksheet, you'll see that there's answers provided for you, so you can check your work there. Should be pretty straightforward, but send me an email or put a discussion question out there if you have questions. So the main units of pressure that we're going to use are ATM, millimeters of mercury, inches of mercury, kPa, and PSI. So mmHg is millimeters of mercury. That's how high a column of mercury will be pushed in a barometer. ATM is atmospheres. That's kind of our standard unit of pressure. 1 atmosphere is standard pressure. Inches of mercury, here we are in the United States. We're the only country that uses non-metric measurements, and so we see a lot of things in inches of mercury, especially when we look at the weather. Kilopascals, that's another unit that's used frequently, and then PSI, pounds per square inch, often used in industry. So yesterday in class, we said we had measured the barometric pressure to be 29.99 inches of mercury. And so the question is, how can we convert that into some of these other units? And so really what this is simply an exercise in unit conversions. And so we're going to simply set up a conversion in kind of like a pick a fence like we've been doing in the past. So we'll start with what's given to us there, the 29.99 inches of mercury. And then we want to set up a conversion factor. Let's say we want to convert that to millimeters of mercury. So our conversion factor are these relationships that I have up there already. 29.92 inches of mercury is equal to 760 millimeters of mercury. And so we multiply across 29.99 times 760 divided by 29.92. I'll do that on my calculator here. 29.99 times 760 divided by 29.92. And we get a value of 761.8 millimeters of mercury. I used 4 sig figs because I had 4 sig figs back here in my original measurement. Now let's suppose I want to convert that to something else. suppose that instead of millimeters of mercury, let's say I want to know how many kilopascals that is. So again, I can set up a conversion here, 29.92 inches of mercury. That'll cancel out the inches of mercury unit. And then what unit do I want to know right there? Let's suppose that I want to find out how many kilopascals that's equal to. Well, the conversion for kilopascals is 101.3 kPa. And so 29.99 times 101.3 divided by 29.92 is equal to 101.5 kPa. And so you see that these units that are up at the top here, we really need to memorize those. On the worksheet that you're going to work on, they're going to be given to you, provided for you for reference, but really they're units that you want to be familiar with. Anytime that you hear talk of standard conditions, standard conditions is STP, standard temperature and pressure, and standard pressure is any of these values up here. They're all the same pressure, okay? They're just expressed differently with different units. So 1 atm, 760 millimeters of mercury, they're all the same thing. The pressure doesn't change between them. It's just the way of expressing that pressure changes. And those are that's standard pressure. 1 atm is standard pressure. That's equal to 760 millimeters of mercury, or 101.3 kPa. Those are the most common ones that we use, is the atm, the millimeters of mercury, and the kPa. I give you the other ones because here in the United States we use inches of mercury, and oftentimes we're familiar with PSI with our car tires or our bike tires. Hey, so we're going to start off here talking a little bit about pressure. And there's a definition of pressure. You're going to learn more about that in physics next year, but it's explained in our book in section 2. Pressure can be defined as force divided by area. And a way to think about force is mass times acceleration. And so manipulating these things, and really mainly it's the acceleration that we can manipulate, it's the force that we can manipulate, or the area that we can manipulate. And so any way that we're able to manipulate those variables can change the pressure. So if we kind of think of force is related to the acceleration, and the acceleration we can think of a little bit like the speed. I know a physics teacher wouldn't have a cow right now if I said this, but for our understanding here, we're going to think of it like speed. And when we think of speed of a gas particle, we really want to think about the temperature at which that gas particle is. So the hotter the gas is, the faster the gas particle is going to be traveling. So if it's traveling faster, it's going to exert a greater force. If it exerts a greater force and the area has not changed up here, and the area has not changed, then the pressure is going to increase. Okay? If the temperature goes up, but we want to keep the pressure constant, then if temperature goes up, then area has to go up as well in order to keep the pressure constant. So if we can keep this in our mind, the relationship here with pressure is equal to force over area, that's going to help us really understand these gas laws and why a change in one condition will affect another variable. So why does a change in area affect the pressure? Why does a change in force or temperature affect the pressure? If we think about it here a little bit too, we said if you squeeze on a balloon, that it's going to get smaller. Okay, so if you are essentially increasing the pressure, you haven't done anything with the force. And so in order to keep this relationship true, if you've increased the pressure, you're going to have to decrease the area in order to keep that relationship constant. And so And we're going to see that in a lot of the gas laws that we look at here. Now, I drew a little box here, and a gas particle is going to move around in straight lines until it bounces into something. And so when it bounces into something, it's going to bounce off of that and then keep on traveling in straight lines until it bounces off of something. Again, what's it going to bounce off of? It'll bounce off the container walls or bounce off of another particle. If we change the volume, then that gas particle has less room to move about, and it's going to bounce off its container walls more. And so that's going to exert a greater pressure. Again, we could even narrow it down even more. In that it's going to hit the container walls more often, and so it's going to result in greater impacts against the container walls, which is going to increase the volume. So that's another way that you can think about that relationship between pressure and volume. And we're going to explore that more as we get into the combined gas laws. But really today is just talking about units of pressure and how we can convert between those units of pressure.